Hello student, welcome to the new session. So last session we have done with the Rutherford atomic model. So this session we are going to discuss the very important topic that is called as the electromagnetic waves. So after this we will discuss about the photoelectric effect. After that Bohr atomic model we will discuss. Now you can see what is the electromagnetic waves. So electromagnetic waves theory, this is also called as the radiant energy theory or EM waves. EM stand for electromagnetic waves. So what are the characteristics of the electromagnetic waves? How many types are there? What is meant by frequency? What is meant by wavelength? What is meant by time period? What is meant by amplitude? Everything we will discuss in the detail. So before going to the discussion of the different type of the terms, we have some introduction about the electromagnetic waves. What is meant by electromagnetic waves? You can see that here, according to this theory in the sense electromagnetic wave theory, the energy is transmitted from one body to another body in the form of waves. These waves travel in the space with a same speed of light, that is called 3 into 10 to the power of 8 meter per second. And these waves are known as electromagnetic radiation or radio energy. So these are the energy from, they will transfer from one body to another body. So in the form of the electromagnetic waves they are traveling. So one energy is there. If you want to transfer from one body to another body, it will transfer in the form of the waves only. It will transfer. The type of the waves we are calling it as a electromagnetic waves we are calling, and radiant energy we are calling. They will travel in a space with the same speed of the light. So they don't require any medium. They don't require any medium to travel these electromagnetic waves, and they travel with the speed of same like a light. That means 3 into 10 to the power of 8. So electric field and magnetic field is associated with this. For example, you can see that. For example, so one wave is there. So you can consider this is the wave propagation. This is wave propagation. So you can consider this is the wave. So you can consider this is the electrical field. You can see the magnetic field. So downward, for example, you can say parallel they are associated. This is the electric field, magnetic field, electrical field, magnetic field, electrical field, magnetic field. Like this, they are associated. That means if electrical field is there, definitely there would be a magnetic field is there. So now we will discuss about some of the important terms of the waves. Before going to discuss about the detail, we have to discuss some basic things. We have to discuss. See some important terms: crust and trough. The uppermost point of the wave is called crust. The lowermost part of the wave is called as a trough. So if you see that, if you can see any wave, this uppermost part they are called, it is called as a crust we are calling. This lowermost part is called as a trough. So this is crust, this is. So that means how to understand that the wave is associated with the two parts. The first part is called as a crust. Of course, not a first part. Highest, the most uppermost point is called as a crust, and the lowermost point is called as a trough. This is the characteristics of the every wave. Important term, wavelength. So it is denoted by the symbol is called lambda. It is denoted by the symbol is called lambda. It is denoted. So if you see the wave. Once you observe the wave, you can easily understand what is the difference between what is meant by the wavelength. So this uppermost part is called as a crust we are calling. So this is also called as a crust. So this is also called it as a crust. So the lowermost point is called as a trough we are calling. So this is also called as a. So if you see the definition along with this diagram, it is defined as the distance between the two nearest crust and two nearest trough. So that means for this crust, this is the nearest crust. So this from the distance, these two distance we are calling it as a lambda. and these two distance we are calling it as a lambda we are calling. If you take the two nearest crust you can take, or you can take the two nearest trough also you can take. So we are talking about the some distance we are talking about, distance between the two successive crust or two nearest crust. So two neighboring crust or two neighboring trough. That is only we are calling it as a wavelength we are calling. So wavelength you can measure in the angstrom you can measure. So 1 angstrom is equal to 10 to the power of minus 10 meters, and you can measure in the 1 nanometer. 1 nanometer is equal to 10 to the power of minus 9 meter. You can measure this one in a 1 picometer also. Picometer is equal to 10 to the power of minus 12 meters. We are talking about the distance. You can measure in the meter and the centimeters also you can measure. So this is about the wavelength. That is just the distance between the two successive crusts or two successive trough is called as a wavelength. It is denoted by the symbol is called lambda. Next one. So velocity. So velocity is nothing but distance covered by the wave in a 1 second. So otherwise you can take it that in a given time how much distance is covered by the given wave. So you can modify this distance covered by the wave in a 1 second. That is only we are calling it as a velocity we are calling. So next one you can see the amplitude you can see. So this amplitude is talking about the height of the crust. So this is the crust. This is the so height of the crust or depth of the trough. So you can write height of the crust or depth of the trough. So amplitude is different for different waves. It is different. Some places crust will be high. Some places depth of the trough will be high. So amplitude is different. So velocity is nothing but distance covered by the wave in a 1 second. Frequency, this is called as the mu we are calling. So it is nothing but the number of the waves passing through the one point in a 1 second. So in a 1 second how many waves are passing? Based on that only we will calculate the frequency we have calculated. So we have some formula also. You can see that the number of waves passing through the point in a 1 second. So I can write distance. By unitary method we can get the formula distance covered by the waves and the number of waves. So I am talking about distance. I can take lambda waves, number of waves 1. So for example 1 is a by unitary method 1 into 1 by lambda. For example if I take this is C. So distance covered by the wave C. So then I can write C into 1 by lambda. Nothing but frequency mu is equal to C by lambda we are writing. So C is nothing but the speed of the light. Lambda is nothing but the wavelength. Lambda is nothing but the wavelength we are calling. So you can see that this is velocity of the light meter per second. This is the lambda is equal to meter. So get cancel. You can get the second inverse you will get. Or you can take it as a hedges also, you can go with the frequency. So mu is equal to C by lambda. You have to remember this formula. Based on this only we will do some of the numericals we will do. Time period T. T is nothing but time taken by the waves to pass through the one point, from one point to another point. So it is reaches the how much time it is taken to reach the one point. That is what we are calling it as a time period we are calling. So you can see that number of waves. We want the formula. By unitary method we will get the formula number of the waves and time. How much time it has taken. So you can see that for example I am considering the mu waves I am taking. It is 1 second. So 1 in the sense it will get 1 by mu. So nothing but time period is indirectly proportional to the 1 by mu. So time period is nothing but the 1 by mu seconds it is. This is also important formula. Wave number, this is called mu bar we are calling. Mu bar is nothing but if you see that, so it is the reciprocal of the wavelength. That means mu bar is equal 1 by lambda. How do we have to understand this in the sense? That is the in a given centimeter. For example, from here to here the distance D I am calling it as a D. So this is I am taking in the centimeter in a given 1 centimeter. For example, this is like a 1 centimeter. In this centimeter, how many number of the waves is present? So the number of waves will also change from the place to place, but in a given distance, you can call it in a given distance, how many number of the waves? That is what we are just modifying that. It is the number of the waves present in the 1 centimeter. So this number varies from, that means wave number varies from the distance to distance, it is varies, from place to place it is varies. So you can see in the given centimeter, how many number of the waves is present, that is only we are calling it as a wave number we are calling. So we have a formula mu is equal 1 by lambda. You can see that distance covered by waves, distance covered and number of the waves. For example, I am talking about the lambda, number of the waves 1 only, distance is lambda. Why? Because lambda is nothing but the wavelength, the distance between the two successive crust and two successive trough. So distance, this much of distance, how many waves are there? One wave is there. For example, if I am talking about the 1 centimeter distance, how many waves will be there? 1 into 1 by lambda. This is only we got the formula mu r is equal 1 by lambda. So by using the unitary method, you can understand the formula of the wave number, you can understand. Radiations, we have understand what is the meaning of electromagnetic radiations. So energy transfer from one body to another body in the form of the waves, that is why we are calling it as electromagnetic waves. We are calling electromagnetic waves not required by any space. They will travel with a speed of 3 into 10 to the power of 8 meter per second. They are having the electric field and magnetic field associated with them. So you can see that some electromagnetic waves, for example, you can see how many types of electromagnetic waves is there. So for example, you can see radio waves, microwaves, infrared waves, visible, ultraviolet, X-rays, gamma rays, cosmic rays. So this sequence you have to understand. So radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays, and so here you can see that energy is increasing. C by lambda, nothing but mu inversely proportional to the 1 by lambda. So here you can understand that lambda is decreasing. So wavelength is decreasing, energy is increasing. Okay. So automatically by using this formula you can write mu also increasing. Frequency is increasing. Energy is also increasing. Lambda is decreasing. This chart you have to understand. Radio waves, microwaves, infrared, visible, ultraviolet, X-rays and gamma rays and cosmic rays. If you want to remember this, go with this mnemonic. So just remember this statement. Remember me, I am very useful, exciting. In the exciting you can go with the this spelling X. Don't go with the EX, go with the exciting girls. So here, if you remember the statement automatically you can remember this sequence. So R stands for radio waves, M stands for microwaves, I stands for infrared, V stands for visible, U stands for ultraviolet, X stands for X-rays, G stands for gamma rays and cosmic rays also you have to remember. Electromagnetic waves, types of electromagnetic waves, the radiation having the maximum wavelength, ultraviolet rays, radio waves, X-rays and infrared. So they are asking about the which is having the among the following which is having the highest wavelength, lambda they are asking. So once you remember the chart, radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays, gamma rays. So radio waves from top to bottom, you can see that from lambda is decreasing. Radio waves having the maximum wavelength they are having. So from here to here wavelength is decreasing. So from these questions you can say that option D is the correct.